One of the defining traits of modern computing is that we keep building systems that are casually essential, not formally or intentionally essential, just casually. And this can look like an exchange server that no one really wants to migrate, or more and more frequently, AI tooling that is becoming part of how vulnerabilities are found and understood. And it's never really part of anyone's security model at first, but over time, they become load bearing. And usually, the first people to fully realize how important these systems are aren't the organizations running them, but rather the attackers looking for leverage. This week, we're talking about a malicious VS Code extension that compromised thousands of GitHub repositories, actively exploited 0 days in both Microsoft Exchange and Cisco SD-WAN infrastructure, AI accelerating vulnerability discovery on both sides of the line, and somehow AWS GovCloud credentials ending up in a public GitHub repo. This is Initial Access. I'm Sean McMillan, Community Manager here at Bishop Fox, and this week I'm joined by Shad Malloy, Managing Senior Consultant 2, and Emilio Gallegos, Adversarial Operator 2. Thanks for joining.
Thank you.
Hey, thanks for having me.
First up, I want to talk about this story from Bleeping Computer, GitHub confirming that around 3,800 internal repositories were compromised after an employee installed a malicious VS Code extension that stole developer credentials. And what kind of stood out was the attackers didn't break into GitHub, right? They targeted the developer upstream of the pipeline and then used legitimate credentials to make their activity look totally normal. And GitHub has since linked it to Team PCP back in the headlines, second week in a row. The same group associated with the mini Shai Hulud supply chain that we talked about, which really raises the question of where the most valuable trust boundaries actually are now. I guess to start with, what does an attacker gain by compromising a developer's local environment versus specifically targeting CI/CD pipelines or the repository directly?
I'm interested to hear Amy's response to this, but I think any good enough developer, above a certain level, is going to look exactly like an attacker. Like you're going to be pushing to repos, pulling data, using credentials potentially in odd ways, not directly malicious ways, but your lead developer probably is accessing the credentials in a slightly different way than your junior developers. And I think it would be hard to fingerprint on that. So that's...
Yeah. Are there any ways that you know of, either of you, to kind of tell the difference?
So just before I go into that, I think you nailed it pretty much earlier when you said that attackers are not even targeting GitHub's own infrastructure, right, anymore. If you think about it, a developer machine is much earlier in the chain, right?
Yeah.
If you compromise the CI and the CD pipeline, then you're essentially attacking a system that probably has logging and approvals and some other forms of monitoring. But if you compromise the developer's local environment, then you get a lot of extra context that actually feed those systems, right? You may even get credentials, or regardless of the local source code that he may have, is more about just all of the extra things that he has locally, right? And the second question, it is extremely tough in my opinion, right? Because like Shad mentioned, it's not like there's a specific fingerprint, because you're no longer talking about exploits, right? It's more about behavior, and that's extremely tough to pinpoint. Just something that I could think of is just thinking of geolocation. If you start seeing traffic from a different place where your developers are, then that could be a fingerprint, right? Or if you're seeing that a specific developer is cloning all of your repos all of a sudden, then that's another iffy thing, right? I think that's a conversation that everyone needs to have, is what exactly can we do about it? Because this is only rising, right?
Yeah.
I used to tell people it takes a year to run a log system to know what your log system should look like, just because you need that kind of background of all what does my behavior look like versus his.
Mm-hmm.
I think, and I hate to use AI, but maybe since we have a lot of historical data on that, this would probably be a good use case for AI. I mean, it's good at searching for patterns.
Yeah.
But I think kind of to abstract back one layer for that, I feel like we just keep adding places in the system where you can add untrusted code. We have browser extensions. Those are pretty untrusted. These are basically an untrusted extension. I mean, you have to get it into the Microsoft store, but I think this isn't the first time that they've had a malicious code pushed into the into the store, and like attackers did a good job. I think they took a valid one, ran it for a while, and then flipped it to malicious. Maybe we just need to stop letting people install things.
Shad is quickly becoming like the stereotypical IT guy that just says no to everything.
Okay. Here
And
is a fun
it's the
story.
right call, but I get it. Yeah.
I worked in Los Alamos. My job was to tell people no and to tell them, I'm not going to do that thing because we're all going to end up in jail.
Right.
But there's only like 3 places in Los Alamos. It's very small. And I would meet them, like having lunch or something. I would be chatting with them and they're like, we thought you were a terrible human being. They did not use that. They used a much more aggressive word. And I was like, yeah, but you keep asking me to do illegal stuff and my job is to keep us all out of jail. So if you
Right.
stop that, like
Yeah.
I would not have to be as big of a jerk. So,
We're all still free, aren't we?
right.
All right, let's move on. Talk about this Microsoft Exchange 0 day. This is also from Bleeping Computer. Microsoft disclosed a 0 day in on-prem Exchange server that was already being actively exploited in the wild before public disclosure. Flaw can let attackers execute malicious JavaScript through Outlook web access using a specially crafted email. And Exchange just keeps showing up in these stories because it sits in such an awkwardly powerful place inside enterprise environments, handling email, authentication, identity flows. In a lot of organizations, it's kind of adjacent to basically everything important. So Microsoft didn't even like have a patch ready immediately. They pushed organizations toward mitigations first through the Exchange Emergency Mitigation Service, which is kind of its own commentary, I guess, on how compromised these timelines are becoming. Why do core messaging and identity infrastructure components such as Exchange keep appearing on these lists? And what does that say about how enterprises are really managing their foundational risk?
Well, I feel like first things first is just that email is not just email, right? At the end of the day, it contains like you name it, right? Password resets, whatever internal conversations about vendors, clients, voices. You can even have like threads of a specific issue that happened internally. It's essentially like I wish an ASI would be here to talk about this, but it's essentially like an intelligence source in some regards. It gives you a level of visibility into that organization that you just couldn't find by targeting a specific application.
Yeah. I mean, it's like the modern paper trail.
And even especially like for big companies like that, they have like a special legal hold setting, so that even if you think you've deleted it and the admin thinks you've deleted, if you've marked that box as legal hold, it's never going away.
Uh,
But I think for this also, the simple mitigation, this is how I purposely don't get hit by these things, is I just don't check my email. Like you can't fish me because
right.
I'm not reading it. So
Email? What email? So one interesting thing here is Microsoft leading with mitigations instead of patches. So we talk about timelines a lot, but kind of what does this say about how attackers are finding or sharing vulnerability intelligence in advance of public awareness?
I think for this specific one, and I don't know how they are injecting the code or anything, it might be a difficult rewrite to sanitize out all of that injected code for the cross-site scripting, but it might be easy for them to roll out just like a regex filter and say, if it looks like this, just drop it, kind of as a
Yeah.
pre-mitigation to help people until they can rewrite whatever the backend. I mean, it's like layers of defense, right? And if that's the correct layer, until you can build a bit higher wall, like close the door at least.
Do what you can when you can. Yeah.
And I think just to add to it, I mean, something to always keep in mind is just that the disclosure timeline is not necessarily like the attacker awareness of these bugs. The whole thing of Microsoft publishing mitigations before a patch, I mean, that usually means that either defenders were aware of this and needed protection immediately, right? Or
Right.
exploitation was already happening or it was likely imminent, right? So we can all theorize as to how they may have found it or how they share it privately, but I think that's just one thing as a defender you need to be mindful of. Even if you're reading like patch notes or you're reading a security update or whatever it is, you must know that there was already someone who is aware of this and is probably looking at your systems for it.
Yeah. And like I said, with what we're seeing on timelines changing so much, I think, well, let me ask, what do you think? Is this something that is likely to be more common going forward as I mean, it almost seems like this is Microsoft. This is not like someone you really catch unawares, so to speak. But do you see more organizations having to kind of be more agile and just take these steps instead of more traditional patching?
I think so, and I think fingers crossed we don't see like another like CrowdStrike issue where they roll one out that breaks a lot of systems. But I mean, like, I think we're all just going to have to get a little bit more tolerant of speed versus safety, especially for if an issue has enough impact, I would accept a little bit more risk that it's not fully tested,
Yeah.
rather than be exposed for 50 days or something for a patch.
All right. Well, let's move on to our third story today. This is from HelpNet Security. Cisco patched another actively exploited zero day in its Catalyst SD-WAN platform, specifically an unauthentication bypass in the controller and management plane used to orchestrate traffic across distributed enterprise environments. This is the second SD-WAN authorized auth bypass Cisco has patched in a relatively short window, which kind of starts to look like sustained interest in network control infrastructure itself. According to Cisco and Rapid7, attackers could abuse the flaw to authenticate as a high privileged internal user and ultimately push arbitrary configuration changes across the SD-WAN fabric. So researchers also noted overlap with infrastructure associated with ORB networks, which Mandiant has previously linked to China Nexus espionage activity. So taken together with the exchange story, you start to see attackers kind of focusing more and more on the connective tissue that these big organizations, big environments kind of depend on. What is it that makes SD-WAN and network orchestration platforms such a consistent target for these kind of actors compared to endpoint or app layer type attacks?
I think a few things. One is that once you're inside the fabric, there's not like, EDR running on your Catalyst. Like you might be able to catch some weird flows. Like if you really understand Cat OS, like you might be able to find like a tunnel where they're like stealing data and stuff, but it's much more difficult, and I think it's easier to hide. Not for me, definitely not for me. You do not want me on your Cat OS trying to set up like extra routes and stuff. But I think, these are probably like highly skilled people who've actually read the books. Like
Yeah.
it's a great, like you have great visibility into the network, and you can take things out and put things in. If you add your own site as, somewhere into the fabric, now you just look like a trusted router inside there.
I mean, and to add to that, essentially with endpoints, dealing with endpoints or at least attacking endpoints, you can get pretty noisy pretty quickly, right? And those are heavily monitored. Whereas dealing with something like a network platform, first and foremost, it's fewer in numbers and usually they're more privileged, right? So another critical point, and maybe I'm calling myself out on this one, but it's also that it's often less understood, like Charlotte said. Outside of the network team, very people actually understand what's happening, right? So
Yeah.
Yeah, I've had to deal with Cat OS and iOS, like the Cisco one. They're the similar, but they're not the same. Like even though they kind of do the same functionality, like I was struggling. Like if you just dropped somebody in there, if you're like, hey, Chad, you're going to do the incident response on this, I would cry for a little bit, but then I would like have to go find somebody who was way better than me.
Yeah. I mean, is this kind of pattern of auth bypass, is this because attackers are concentrating more on this kind of systems now?
Are they concentrating more on there, or are we getting better at finding them? Like, have they been in there for a
Sure,
while?
sure.
Like it seemed. I believe
Like
this.
survivor bias. Yeah.
Yeah, I believe that this is from an acquisition. Like Cisco acquired this
Uh,
technology from somebody else. So is this just a long tail of tech debt from, whenever they bought that? And maybe it was, cutting edge code at the time, but now we have some different security tooling. We have like different processes and how we think about locking that down. I'm not 100% sure how to think about that. Cisco's a huge company. They have probably boardrooms full of people thinking about this right now.
yeah. And here we are, the three of us trying to solve it for them. We got you, Cisco. Yeah. All right. Well, let's also talk a little bit about this is kind of two stories here. First up from Axios, Palo Alto says Anthropic's Mythos and OpenAI's GPT-5.5 Cyber helped researchers identify 75 legitimate vulnerabilities across more than 130 products in about a month, roughly 7 times their normal discovery rate. And the surprising part, I guess, was that these models were actually good at chaining smaller issues together into realistic attack paths, which is not what we've traditionally seen with AI. The second part of this is from The Verge saying that Google disrupted what may be the first confirmed AI assisted 0-day exploit intended for real world deployment. Researchers said the exploit script showed a bunch of LLM fingerprints, like hallucinated CVSS scores, overly structured formatting, educational style comments, basically the stuff that Richard Brown would say looked a little too textbook. So taking all this together, the overall story here is not about look at AI hack, but it's like vulnerability discovery, exploit development. Those timelines seem to be compressing at the same time, and they're chaining. So when they can do that, and they can chain these low severity findings into realistic attack paths faster than a human could, what's that mean for how organizations are prioritizing remediation?
Well, I don't think that this is like brand new, but it definitely changes or at least adds to the urgency of things that as an organization, you can't really look at low and medium findings like isolated, right? A medium
Mhm.
issue by itself, again, it may not look as bad, but if you combine it with another bug, like an exposed admin panel or just whatever that may seem like low hanging fruit, then it can become an entire different thing. And I say this all the time as well in continuous pen testing that I do is just with AI now it's everything 2x.
Yeah. Or 7x in this case.
I think definitely it has like raised, I guess either lowered the ceiling or raised the floor, however you want to think about it. Like B team people now are definitely able to put out like A team work. But to defend what he and I do, there's always that creativity jump that I don't think like it can chain them together now, which like we were saying, it wasn't doing it. But I think what the human brain can do is look at two informationals, a low, like a half remembered dream you had one time and be like,
Yeah.
I think I can make that work. I think that's always going to help us find all those things, but that there's always going to be that little spark, that little jump that like you just can't
Yeah.
program it because it's like a glitch in the matrix or like a misfiring neuron.
Yeah.
Something just gets you
Well,
over a hump
I
sometimes.
think part of that too is the experience. Like if you've done something similar to this before and the light goes off for you because you know that like, oh, I see how this and this would work. AI is looking at it purely from this isn't really the right term, but more of like a data perspective, not in a hey, I've done this X amount of times. I know this works. So yeah. But this does also feel like one of those when we talk about AI as an attacker or in whatever context, you always kind of say, well, it's great, but it can't do this yet. At least there's we
Yep.
can take
Yep.
chaining attacks off that list now. We can flush
At
that.
least I can pay my bills for another. How long is it taking them to put models out? 6 months?
Right? Yeah, exactly. Start planning. um, yeah. So, what about this type of assisted exploit development? What does that change about the relationship between like vuln research and weaponization, and that expertise floor that you were talking about with B teams being able to uh, play in the majors, basically?
And I think it's going to drive down time to discovery, time to exploit. It's
Yeah.
probably going to drive down prices too. Like, because you
Mhm.
used to be able to sell bugs for a significant amount of money. So if the company's finding their own and patching them, and then also everyone is flooding them with CVEs, I think
Yeah.
it's got a weird economic effect. I don't know about, I don't like do a lot of bug bounties or anything, but I wonder how many of them are getting flooded with AI slop, but also really good bugs that are really poorly written up that get thrown in the AI slop bucket that aren't like, it's just the person who reported that didn't read the output and couldn't really clearly define how bad something was.
I would say that at the end of the day, a person still needs judgment, right? Because it definitely lowers the effort between, oh, I have this lead, I have this finding, whatever it is, and actually trying to get it further, right? Not delegating the entire process, because if you get to a point where you used to have like a supposed finding, but you don't have like any understanding of the target, the environment, or any other constraints, then how are you even going to review or assess if that's a real thing? You have to then look at everything and go back and do it yourself. So at that point, you're not even saving time. So I think that expertise and judgment is always going to play a big part of it.
I mean, I'm sure Emmy's run into this before where you send an exploit, you know it's vulnerable, everything, you send it and it just fails. And you're just like, is something on the other side killing it? Is this a honeypot? Like sometimes you can tweak something and get it to work, but it's not deterministic why it failed. Like you couldn't give that to an LLM, it'll just say, no, it didn't work. He and I would look at it and be like, maybe I'll jiggle this and I'll add this thing. And, sometimes you can get it to work, or maybe you just send it again. And it just failed the first time, and who knows?
Being hard headed sometimes pays off.
Yeah, absolutely. All right. And finally, we have from Krebs on Security. A CISA contractor accidentally exposed highly privileged AWS GovCloud credentials in a public GitHub repository alongside plaintext passwords, internal deployment files, tokens, and access to what appears to have been parts of CISA's own development and software infrastructure. That sentence hurt to even read. One important detail here, though, is that it didn't require any exploit chain or anything. According to reporting, it basically just required a GitHub search. Researchers said some of the exposed credentials even remained valid for roughly 48 hours after disclosure. The irony that this happened at CISA is not lost on me, but I think the real point is just how much modern infrastructure now hinges on credential hygiene and operational practices instead of purely technical vulnerabilities. Because as we have discussed, like trusted cloud credentials, once that's exposed, you don't need to break in or do anything tricky. You just ride that trust in. So from an attacker's perspective, like, I guess, what does an attacker do with GovCloud credentials in the window between exposure and rotation? You've got 48 hours. What's the plan?
Steal everything and then put in your continued backdoor access. Like this happened because they disabled a default security setting. Somebody went in and was like, no, it's cool. Just let me keep uploading like passwords and stuff.
Yeah.
Like, somebody threw something across the room when they saw that, like, because they said it seemed like it was like an admin who was kind of using it to keep like his deployment notes and like super secret Excel spreadsheets and stuff. As a former government contractor, this hurts me because you don't want people looking at you. If you've already, have they cut about 30% of CISA already? You don't want to be
Something like that. Yeah.
you don't want to be on that chopping block.
No.
But I've talked to like other better cloud operators than myself, and 48 hours, they could steal everything. Like
Yeah.
they would fix your problems for you. They'd be like, I don't like how that was deployed, and then steal it.
Jeez.
You know who's really, really good at AWS is Claude. Like it's read all those, but like it's had me run commands and I had to like go look them up. I was like, I didn't even know that command existed to check that thing. And it was like,
Yeah.
like you're running at script speed, like however fast your console can run and it can return commands. Like that's how fast you could steal it.
Yeah. But I mean, what CISA aside, I guess CISA included, but just more broadly, what does this kind of slip up really say about the gap between security posture that organizations are responsible for enforcing and the operational practices that are actually going on in those organizations? And how
So
can that be bridged?
There should be a NIST control. Somebody out there is finding that NIST control and is like, why weren't you requiring like that two-factor authentication PIV card? What other security controls did you disable to make this thing work? Because it honestly shouldn't have worked. And somebody who has had a job like me is going back and looking through that authority to operate package, and somebody's about to have a really bad couple of weeks auditing that.
Yeah.
It's
Like
it's a
what
long
else
process.
did this operator do?
Yeah,
If
can
he's
you
the type
trust
to
anything?
have just disabled that, what else has he done and how long has he been there?
Bad days all along.
Yeah.
I guess we can just summarize it and say that at the end of the day, it shows that policy and practice, like they're different things.
Yeah.
And we can bring this back to the last one so there's always that creativity gap that gets us pen testers into systems. And there's that
Yeah.
creativity gap that lets other people do something so colossally dumb that lets us get into the system. So like
Right.
that knife cuts both ways.
Sometimes it's just, you just make it too easy. I love to end these episodes on such positive notes.
I would like to have been the person sitting there looking at those credentials being like, this can't be real. Like, there's no way. Is this a honeypot? Like, I'm going to go to the coffee shop and do this in case like the FBI is going to come knocking.
Exactly. Exactly. So, a message to any org out there that's listening to this: when we talk about that gap between your security posture and your actual real life picture of your day to day practices, that's worth looking at. That's worth looking at.
If
Constant review.
I was an ISSO at the government, and if somebody would have come to me and said, hey, I think this guy's doing something weird with the credentials. Can you go look at it? I'm pretty sure this would have gotten caught by like Truffle Hog or one of like the big like credential scanning tools.
Sure.
Like if you see something, say something. Like if it smells bad, go find like your security guy probably looks angry and he will probably be annoyed that you're talking to him, but he would love you forever.
Yeah. At the end of the day, you just earned some actual trust.
Yes.
There. All right. Well, I think that's a good spot to end it for the week. Ed, Emilio, thank you both so much for joining. Emilio, this is your first time. Excellent. Good to have you.
Thank you. Thank you.
And as always, share the show with someone on your team who's thinking about these types of problems. Until next time, stay safe, and we'll catch you next week.
Thank you.
A great one.